The Automatic Direction Finder, or ADF, points in the direction of ground stations called non-directional beacons, or NDBs. It is also capable of navigating to commercial AM radio stations. NDBs are not limited to line of sight, meaning the radio waves follow the terrain and curvature of the Earth's surface. This allows us to receive NDB signals from both long distances and low altitudes. But unfortunately, they also have many limitations to be aware of. These include bank air, shoreline air, electrical air, terrain air, and twilight air, also known as night effect. NDBs are depicted as a circle of radiating dots, purple or magenta in color. This is how they appear on your VFR sectional. Here you can see the identifier, frequency, and Morse code identifier for this NDB. To use ADF, first tune in the frequency of an NDB on your navigation radio and listen to the Morse code identifier. It's important to continue monitoring the Morse code to ensure your ADF maintains accurate readings, because there is no off flag to warn you if you lose the station's signal. Now that you've tuned the station, your ADF needle will be pointing in the direction of the selected NDB. You can simply follow the arrow to home to the station. Keep in mind that if you simply match your heading to the needle, you will end up flying a teardrop pattern. To track directly to the station, you'll need to add wind corrections. This is all you really need to use ADF in the real world, but for exams you'll need to know a little bit more. The ADF indicator you find on your instrument panel will typically come in one of three flavors. There's fixed card bearing indicator, manually adjustable bearing indicator, and RMI, or radio magnetic indicator. Fixed card means the compass card doesn't move. 0 degrees or north is always at the top, and it gives you no heading information. Manually adjustable bearing indicators have a knob that allows you to input the aircraft heading. Some are gyroscopic, and others require constant corrective inputs. The card of an RMI is slave to a compass, so it automatically shows the aircraft's magnetic heading. Like the one in this Beechcraft, they often have two needles and are capable of tuning in a VOR as well. A fixed card bearing indicator will point to the relative bearing. An adjustable card indicator, or RMI, will display magnetic bearing. Relative bearing is the angle to the NDB in relation to the aircraft heading, measured clockwise. Magnetic bearing is the angle to the NDB in relation to magnetic north, also measured clockwise. Adding your magnetic heading to your relative bearing will give you your magnetic bearing to the station. If the sum is greater than 360 degrees, subtract 360 to get your answer. Let's go through some ADF practice questions similar to what you might find on the written exams. This question asks for the magnetic bearing with a fixed card ADF reading of 045 and a magnetic heading of 160. It's easy to figure out with the formula, but I'll draw it out as well. Here's magnetic north, and here's our aircraft on a 160 southbound heading. The ADF is indicating a relative bearing of 045, so a 45 degree turn to the right will take us to the NDB. Remember, magnetic bearing is the angle from magnetic north to the NDB, so we can add our magnetic heading to our relative bearing to get an answer of 205 degrees. This question says that a failed RMI rose is stuck with 090 on top and the needle indicating 245. What is our relative bearing to the station? So since the RMI rose is stuck, this has effectively become a fixed card indicator. In this example, the green arrow is used for ADF, so it's pointing to the NDB. The top of the instrument represents the aircraft heading, so this angle here is our relative bearing to the NDB. 245 degrees is measured from 0 or north, so we need to subtract this 90 degree section here from 245 to get a relative bearing of 155. So you can see if 0 was on top, the arrow would be pointing to a relative bearing of 155. Aircraft heading is 040 magnetic with an ADF reading of 060 relative. The heading to steer to intercept the 120 inbound track at 50 degrees is. This is a fun one. So here's our station, and we'll put a compass rose around it. Our heading is 040, so we're flying this direction. With a relative bearing of 060, we can see that turning 60 degrees to the right will point us to the NDB. Our 040 heading plus a 060 relative bearing means the magnetic bearing to the station is 100. So right now our aircraft is crossing the 100 track to the station. Here's 120, so the 120 track to the station is right here. Since the track is 120 degrees from magnetic north, if we were to cross over it on our current course, we subtract our 040 heading from that 120 degrees. So our current intercept angle is 80 degrees. We want to intercept at 50, so we need 30 degrees less, which means a 30 degree turn to the right to close that angle. This will put us on a 070 magnetic heading, and that's our answer. Last question. An aircraft is intending to fly a 50 degree track between two NDBs. Current heading is 060. The RBI shows a relative bearing of 180 to station A and 330 to station B. Where is the aircraft? So here's the 50 degree track between two NDBs. The relative bearing of 180 shows that station A is directly behind the aircraft. Since we know our heading is 060, we can draw a line from this NDB at 60 degrees. The aircraft position will be somewhere on this line. The relative bearing of 330 to station B shows us that a 30 degree turn to the left will bring us to this NDB. From the current heading of 060, this turn would give us a heading of 030 to the station. 030 plus 180 degrees gives us the reciprocal, which is 210, so we can draw a line from the station B at 210 degrees. Where these two lines intersect is where our aircraft is. So we can see that we're right of track and closer to station B. Hopefully you found this helpful. If you have questions or anything to add, feel free to leave it in the comments. Thanks for watching.